Hello, my lovely humans. Today we are going to look at the 2023 sample paper, question 4, which 2023 sample paper, and it looks like it is a projectile motions with collisions. Projectile motion with collisions. So we're going to see what's going on there, and I'm going to type this one because it's going to get a bit messy and I want to make sure we have it as neat as possible. So let's see. A ball is projected from a point on horizontal ground, initial speed u at an angle alpha to the horizontal. The ball reaches maximum height of h0 above the horizontal. Upon landing, the ball bounces with maximum height h1. The coefficient between the ball and the ground is e. Okay, now I'm not going to look at what the question is, because I know I can't do anything about working out the question until I have set the problem up for myself. And to set that up, we need to figure out the equations for the motion of the projectile through the air, and even more particularly through the air in the first projection before the bounce. We can't do anything until we have that done, and then we can figure out how to use that to find the height for the second bounce. So the first throw we're going to use to find h0, or get something to do with h0, which will hopefully then let us find something to do with h1, I presume, and then it's implying there's another bounce there, 3. So we'll see what happens. So first thing I'm going to do is I'm just going to look at the motion of, or how to describe the motion of this thing. So it's horizontal ground, which means we need to turn any diagonals into horizontals and verticals, and I'm just going to quickly zoom in here. So we got this. This is our projection. It's going at an initial speed u at angle alpha. So what we have to do is we draw a little triangle here, or draw it on your page. I'm just going to draw it here for ease, and we're going to decompose this u into the horizontal and vertical components, and the horizontal component of the initial speed is u cos alpha, and the vertical component of the initial is u sine alpha. And we also know that we have gravity downwards. So that's all we have to do with the graph, or all the stuff we have to create before we can deal with the deal with the equations. OneNote is again betraying me. Okay, here we go. So what I'm going to do is, the way I like to set them up is I'm going to do one column in the table for the x-axis, x direction, and another one for the y. Now that could just as easily be I and j, depending on your teacher's preference, but I'm going to just use x and y. So what we're going to say then is we're going to look at our, do we know anything? Well, we know ux is u cos alpha, and we then know Vx equals u cos alpha, and it'll be minus at, but because it is acceleration due to gravity, which is only vertical, we can get rid of that and just have the v in the x direction is constant, because gravity is the only change, and that's only happening in the vertical. Then we have s of x equals ut, so it's ut plus a half at squared from our tables. So we know that our acceleration is gravity, so the way I would write this is minus g over 2 t squared, or gt squared over 2 if you wish, and then this is cos alpha. So we have an expression for the velocity, and we have an expression for the distance traveled in the horizontal directions at any moment. So that's all we need to do for that one. We could possibly write here ax equals 0 just to be clear that that's what we're doing, but we're going to leave it at that for now. It was more relevant in the previous course to do that so you could prep for a projecting up and down slopes, but at the moment we can just leave it. So now y, so the initial speed in the y direction is u sine alpha the acceleration in the y direction is minus g. Why did I write that there? That's just exactly wrong. Okay, go back to this sx. Let's rewind a little bit. There is no acceleration in the horizontal direction. So the plus a half. So I wrote out the formula intentionally so I could then ignore it. But that half at squared, the acceleration is 0, so that thing goes away because there's no acceleration in the vertical, so apologies for that. But I'm leaving in any mistakes I make here because I want you to see that applied maths is something where mistakes happen, and it's okay, and it's just trying to spot them as you go. So then try third time, Vy is u plus at from the formula. So now u is our u sine alpha, and then our a is minus g, so it's minus gt. So that's our velocity at any moment. And then we have sy, and that's u sine alpha t minus, and this is where it's minus g over 2t squared, so a half at squared. So that's what we know about, I suppose, about how the equation starts. We've split our initial speed into our horizontal and our verticals, our x's, y's, or i's and j's, depending on what you could so it could be that. You could do it in i's and j's if you wish. It depends on your perspective on how best you understand things. So this is what we got going on. We have everything in the left, right, everything in the up, down, and we have links between them. We know certain things. We know, for example, and this is probably not useful, we know at t equals 0, sx equals 0, and sy equals 0. So that's something we know. Don't know if it's useful for us, but it's true. We know, okay. We know the maximum height is h0. Okay, so we know max height is h0. So the max height, so that would be sy max is h0. Okay. So okay, well, actually, before we look, we need to see what the question actually is. So let's have a look at what the question itself is. Let's see. So I reckon it's something to do with H0 and H1, but we'll find out now. Open 20 sample. Sorry, I closed it down to save processor, but actually I forgot I'd need to open it again to read the rest of the question. No, Mr. AI Assistant, I do not want a summary for a long document. Question 4. Right, okay, so question 4. The applied maths paper is such a long paper, just paper-wise, before it will fit on 2 pages. So what do we need to do now? Here we have to, first question is, okay, so the first question here is calculate H0 over H1. Now I reckon the answer is just going to be E or something like that, but we have to figure that out. So we have to find out what H0 is. So we have to get H0 before we know what to do with H1. So let's see, we have at the max height we've H0, but we know at the max height the vertical velocity is equal to 0. So, or the vertical velocity Vy equals 0. So the way I can like to think about it is thinking about how do we link the heights and the velocities, and we linked it through time. So when the max height is h0, the vertical velocity or speed or component, whatever, is equal to 0. So when is the key. By saying the when to yourself, it'll remind you that you need to use our time equation. So we got both of these things. Or not use the time equation, just use the time variable to link the two things together. So we got this stuff. So step 1 will be find when Vy equals 0. Then put this t back into Sy and see what happens then. And just to be clear, the kind of writing it here doesn't work. It's sine alpha times t. So it may not look as clear in the typing with the thing, but it's not sine alpha t, it's sine alpha times t. So let's do first step. So that would be 0 equals u sine alpha minus gt, which gives us gt equal gt u sine alpha, which gives us t equals u sine alpha over g. And a lot of this, you'll see this a lot in your practice with questions, that the time at the max height is always something that looks like this. So what we then do is we then put that into, we have a time, so we put that back into our Sy equation, because h0 is a height is an Sy. So we then say h0 equals u sine alpha times t, which is u sine alpha over g minus g over 2, and then it's t squared. So I'm just going to copy that thing because that's t. So we'll always also see this, and whenever we have a max height thing, we're going to get something that looks like this, where stuff will nicely cancel out for us. So what have we got? We've got, multiplying at the first bracket, we're going to get a u squared sine squared alpha over g okay. And actually I think we're going to get something similar here. We're using the square. We have our u squared sine squared alpha from the squaring of that top of the bracket, and g squared underneath the line, but there's a g above, so that's going to just go to 2g because of the 2. So that means then h0 is u squared sine squared over g minus a half u squared sine squared over g. So we're just going to be left with that. So that's first thing, is we have something to do with h0, which is good. We have found some thing here. Okay. Okay, so what do we do now? I think now we want to get h1 now, I suppose, and put them one over the other and see what happens. So how do we calculate h1? Go back up to our picture. So what do we know? We know when the thing bounces, it's a collision. And we know collisions, the direction, so any change in speed is only in the direction of the collision. So I'm just going to highlight a couple of things here. So because the collision happens here in the vertical direction, this Vx won't change. That doesn't change at all. So that's going to be the horizontal speed of the particle after it bounces. But what we're trying to figure out is what's going on here. It goes down with a certain speed, then goes back up. And that the back up speed here, the thing I've put the question mark there on, or colored in blue, has something to do with the coefficient of restitution. But what we need to figure out first is what is the speed of the particle as it hits, or the ball as it hits the ground. And thankfully, we have a lovely symmetry here, that if the ball is launched with speed u, because we're negating wind resistance, it lands with speed u. I suppose you can think of this whenever you throw a ball up into the air and then catch it, you're catching it with the same speed at which you threw it, because the journey is up and down is symmetric. So what's happening when it lands then is u cos alpha across, because that hasn't changed. So because there's no acceleration in the x direction. And then if it hits the ground at the same speed u and has the same x component, it has to have the same y component except downwards. So the speed the ball has at the collision is u sine alpha. So we can use our Newton's experimental law here, I think, because quick sketch, what we're doing is it's doing that. That probably should do. It's doing that, and it is going with v sine alpha down, v cos, or u, sorry, u cos alpha across. Then after the collision, it has u cos alpha across still because the collision is in the y. And it's going to be bouncing up to, and we're just going to call that v, because I don't know what that is. So how do we do that? I think we're going to use our Newton's experimental law. I'll just get the log tables up so I can make sure I got it right. So I learned it in the old way. So Newton's experimental law, I'll just type it up here, is, where are we? Page 51, NEL is V1 minus V2 equals minus E U1 minus U2. Now, this thing is one ball, so where's the V1 and V2? Like, how are we going to get that to model the collision? Well, the ground is the other part of that collision, the other half, the thing that creates the reaction. So, because it's ground, you just say U2 equals 0 and V2 equals 0. You don't even have to think of it in that way, but you know, it's good to know if things go horribly wrong, you can still figure it out from first principles. So what that means is our V1 is, and I'll just put that 1 there, our V1 is the speed at which the thing comes up from the ground after the bounce. V2 is 0, V1, and then that's equal to minus E by U1, which was minus U sine alpha, remembering that it's minus because it's pointing downwards. So actually that's just it, is plus EU sine alpha. Okay. So we have our new vertical speed for the ball after the first bounce. Excellent. So I think all we need to do is copy this whole thing here. And I will just copy it down because that makes it easier for me and quicker to explain to you guys. So we copy down the exact same structure, but UX is the same. It's because it's the same vertical speed, same acceleration, same Vx, same Sx, but it's our y direction that is different. So this goes to, I'll just highlight it. So this V1 is this thing. So what I'm going to do is I'm going to just delete the things that are different. So our Vy is what we want to know, or Uy is what we want to know. Oh, sorry, that's what we figured out, and we use that to find out all the other stuff we need to know. There we go. So that's EU sine alpha from the collisions formula we just created, and then a V is EU sine alpha minus GT from our equation of motion, and then our SY is EU sine alpha t, so UT minus g over 2 t squared. And this is why it's really good to set these questions up for yourself in this way, because you have a method, you have something you can look back on and go, that's what I did, I'll do that again now, and it'll all work perfectly. What I think we're told, just to go back up to the question, I presume you're looking at the exam paper as well, or aware of it anyway when you're looking at this, but it is H1 is the height after the first bounce. So H0 is the height of the first throw, h1, the max height of the first throw, h1 is the max height of the first, after the first bounce. And I have a sneaking suspicion that that diagram is going to lead us to do something else. But anyway, so we want to find h, so we want to find h1. And this is exactly the same, exactly the same method as finding h0. I did that. Very strange what's going on there. As finding h0. OneNote is so much fun sometimes. So, right. So what we do is we put Vy equals 0, just to refresh, Vy equals 0 to get t, to find t, and then we put this t into sy for h1. So let's try that. So Vy equals 0, so 0 equals EU sine alpha minus GT. And what that gives us is, I think it's t equals, so we bring the GT over, makes plus, then divide by G, so EU sine alpha over G. That doesn't look the way I wanted it to look. Just give me a second. I want to be as consistent as possible, given that I'm all over the shop. EU sine alpha over G. So that's our time to get to the max height. So then we put that in for our sy. So sy, we know it's equal to h1, or we're told that's what the name to give it. And so that would be EU sine alpha by t, which is EU sine alpha over G, minus G over 2 by t squared, which is our EU sine alpha over G, and that's squared. I don't know what the bracket's doing there, but let's get rid of it. Okay, so hopefully we'll be able, this will let us do something. Okay, cool. So that's what our hy is equal to, or h1 is equal to that. And actually, looking back, I think we have the same thing again. We have a EU sine alpha squared over G, so that would be, and I'm just doing big brackets here. For G minus, we're going to get the same thing. We're going to get EU sine alpha squared, and G over G squared is G, so it's over 2G. Again, don't know why there's brackets there, but let's just leave it as that. Which gives us h1 equals, it's just going to be just going to, so this is one of these minus a half of those, which gives you a half of those. Okay, and so we've got a H1 and we've got a H0. Now we can calculate H0 over H1, which is what the question was all the way back here. Calculate H0 over H1, cool. So let's get this. I'm going to type it out here just so we can see it. So that means then H0 over H1 equals this stuff over this stuff. So immediately the two G's cancel. And I think loads of other stuff's going to cancel, but let's just see for a second. The two G's cancel. And we're left with U squared sine squared alpha all over E squared U squared sine squared alpha sine squared alpha. Okay, and we have the U squareds cancelling, the sine squareds cancelling, and we're left with 1 over E squared, where E is the coefficient of restitution. So that's a nice nice little bit of symmetry there, I think. Okay, so H0 over H1 equals this. I don't know why that's doing that to me. Okay, cool. So that's H0 over H1 is 1 over E squared, which is nice. It's the difference in heights is purely to do with the coefficient of restitution. Okay, then. Now, what's the next part? Okay, there's a page and a half of that. Okay. So the ball continues bouncing. Find an expression. I'm just going to zoom out so we can zoom this in. So the ball continues bouncing. Find an expression in terms of E for H5. Okay. So find an expression for H5. The maximum height of the ball after it lands on the ground for the 5th time. Okay. Now, it may seem like a bit of a cop-out to do this, but this is the mathematically perfect thing, is that our H0 over H1 is the ratio between successive heights, and the ratio between successive heights is due to the coefficient of restitution between the ground and the ball, kind of reducing the height of the ball each time. So what we would want to find is H5. So we can do it in massive gory detail, because you notice that the actual speeds and the actual kind of heights don't really matter, because it's all we get is 1 over E squared. It is purely to do with the coefficient of restitution. So if the coefficient between if the ratio of any two successive max heights is 1 over E squared, we can say that's true. So H1 over H2 equals that. And we can say H2 over H3 equals that. Now, you might be tempted to kind of jump straight to the answer, and that's perfectly fine if you're absolutely confident that you can get the correct thing without without making any mistakes. But so we got H0, H1, H1, H2, H2, H3, H3, H4, H4, H5. Hopefully these things aren't triggering anyone. So we want to find H5. And by writing all these things out, we know exactly how many E2s we're going to need, but I still don't know how we're going to assemble them, or I don't have a vision for that yet. So let's rearrange this bottom one to see what H5 is equal to. And I think that means H4 E squared equals H5. Bringing the E2 up, and okay. Let's do this here. Is H3 E squared equals H4. And this means H2E squared equals H3. And this is H1E squared equals H2. Good God, this is going to be annoying. Now I am doing this possibly the stupid way, but it is the way that the algebra is simple, and so I'm guaranteed that I'm going to get it right. So now we know, now that we've rearranged everything like that, I think it's easy to see. We know what H1 is. We know H1 is H0 E squared by E squared equals H2. Hopefully we can see that. I'll just do a little highlighter there so we can see what's happened. That H1 is that thing, and we are replacing H1 with H0 squared, which gives us H0 E to the power 4 equals H2. Then we just need to put that H2 in for the next equation, and this is just going to work. And it's totally cool to jump straight to the answer if you know how many E2s you're going to need, but it's also totally cool just to do it out one step at a time to guarantee yourselves the correct algebra. It's often better just to write out all the steps, because that will be quicker than thinking and worrying about the mistakes you're possibly making in jumping a bit, but whatever suits. So H0, that's going to be E to the power 6, isn't it? Yeah. Okay, I think that's a nice shortcut to take, that we know it's H2 is bringing E to the power 4, multiplying by the E2. Then H3 is bringing E to the power 6. So that's going to be E to the power 8 equals H4. And it is going to be E to the power 10, which is what I thought it was, but I didn't want to say in case I was going to make things even worse. And then H4 is that, so that's H0 E to the power 10 equals H5. And actually that's the answer. Done. The ball continues bouncing. Find an expression in terms of E and H0 for the maximum height of the ball after it lands on the ground for the 5th time. And that is the question done. There's no marking scheme I can find for this, unfortunately, so I can't really talk about where the marks would be given. But I can it feels like this question 2 would be 10 marks, because there's kind of 2 things of working out to do. The first thing, possibly, no, it could just be 5, but feels like it's 10 marks. That rearranging there, just starting with that to get H1. And then that kind of helps you find the pattern. So there's some kind of marks for finding the pattern, and actually thinking about it like a maths exam. If this is worth 10, so some correct steps, so that would be worth, say, 3. Getting the pattern or spotting something would be worth 7, and then the final answer is worth your 10. So I'd say it's 3, 7, 10, maybe 3, 5, 7, 10 if you do something correct in this middle part. But again, I think by, we know we have something. We have H0 and H1. That's what we have to work with, because it's E and H0. So work with that and then see what we can get. As for this part of the question, I would imagine that, where are we? All the way up here. Okay. I would imagine that from previous marking schemes, writing out these things and that thing is 5. Maybe it's 10, but I reckon it's just 5. Yeah, because it's all kind of the one thing, and you get 5 marks for writing out the same stuff for the bounce later on. So then, knowing this stuff here and getting an answer, I suppose, is going to be 5 marks. You might get 5 for knowing Vy is 0 and Sy is a max. Then putting that in, and that gets you 5 there. Now this is absolutely made up on the spot by me, so I don't know. Please don't take this as any kind of absolute truth. Then using Newton's experimental law is definitely at least 5. Putting this stuff in here is 5 again. Then finding H1 would be another 5. Then doing this would be 5. So my very abstract kind of on the fly way of looking at the marks is 5, 10, 15, 20, 25, 30, 35, 40, 50 marks in total. So to pass it, you need 20, which is always just what I like seeing. So what can we do to pass? So at what point have we passed the question? And the point at which we pass the question is down to here. And this should be fairly standard, or a very similar thing to what you've done in previous questions. This kind of, at the max height, find the time, which is u sine alpha over g, and it's always going to be u sine alpha over g. And then get your answer. So if you've got that first answer, if you found H0, not even H0 over H1, if you just find H0, it looks to me like that would be passing the question. Then some attempt here to get Newton's experimental law going and rewriting it and finding H1 is another 15 marks. And then you've just got a bit more work here. So it's very easy to, without any kind of new work or exam specific stuff, pass the question. Please let me know if this is helpful or not, or if you'd like me to do any other of these similar questions. But the key to this one here is, I'll just highlight it in this box, is the Newton's experimental law. When the ground is one of the things that collides, and the ground has no speed at the start and no speed before the collision, no speed after the collision, therefore it's all zeros. So you just put 0 in, and then that gets you your answer. So once you've done the projectiles, you can then worry about the collisions, which is that one. I will do an oblique collision later, but yeah, I hope that has helped. Let me know, and good luck.